structure, it is divided two parts. The content one is the self-healing the polyurethane material. This paper, it is published in Journal of Material Chemistry, Part C, 2020. Okay, like this journals. So this works is focused on the self-healing polyurethane material and to form the three-dimension printing materials. We have used the materials, the polyurethane synthesis and combination with the self-healing technology to prepare the novels, the self-healing, the polyurethane materials. The PU materials have the many advantages in tunable structure, such as the tunable structure, adjustment to the properties and the simple synthesis process, and anomic application rate. And self-healing materials and the propelling service life and the more stable and safe and lowering cost greatly. So we have developed the self-healing polyurethane material applies in flexible the stem successor, have the special characteristics such as the outstanding flexibility and tolerable mechanical strength and excellent adhesives to materials such as the metal, the glass, and the plastic, etc. A simple synthesis process and conductive to the future scheme, larger schemes of production. The wide selections of the conductive materials, ejectable electrons properties. This is self-rippling the flexible polyurethanes. It is applied to the many industries, such as this picture. So we can the synthesis roles of the two material designs and the synthesis. This is the PU structures, and the end groups is APDI and PUs, and middle structures it is MTDI. It is DMPA. This is the boiling device as the catalyst. And during the synthesis process, we prepares the flexible waterborne polyurethanes, and this is the proposed materials of the waterborne polyurethane PU, U sub X, H sub X cubed films, high elastic, and the touch. Have the elastic touch. This is the mechanisms. So we can waterborne PU cells by continuous isocyanate reactions where X and Y represented the molecules of the UPIs and HEMA to synthesize the processes of ACE elastomers as talking as samples. So it's the cross-linking, and to the cross-linking networks together together, whereas the stressings, so as deformation, this forms, and uh, and release the stress to it is formation, it is to back the ground. So it is have the good elastomer and touch. So it is the spice, two spice uh, with the hydrogen bonds. Hydrogen bonds construct the cross-linkage. Cross-linkage. This is the characteristics, morphologies, and margin particle and molecular structures. This is TEM, and this is DMS. The particle size is about 20 to 50 nanometers. This is the FTIR speakers. So this antinal peak, it is changes before UV curing and after UV curing have the clearly changes. This is hydrogen bonds. Hydrogen bonds to forms the networks. This is the NMR speakers. So we have the characterization the doors networks. This is UV curing the kinetics. It is double bonds. It is double bonds. The UV curing conversions with exposure times. So we can see the highest conversion is up to 90%. So it is with different temperature. This is rich receptors, chemical receptors. So this is different the absorbance, hydrobond. It is dynamic receptors. So this is changes of the hydrogen bonds of the curing after the different temperature. So we can study. We also study mechanical and dynamic mechanical properties of the PUFQs. Sorry. PUFQs, it is the plus of the tangent dirt. This is the activities energies of the hydrogen's uniquels. This is the storage modulus cubes. This is the stress cubes. When we count the stress cubes, it is with the continuous bias adding the systems, the stress it is increased clearly, greens the light. This is to chapter characteristics the cubes and is the cuts patch. This is the orbital cuts crease of the PUAs. PUA after before and the healing. This is the healing. This is the 80 degrees centigrade for healing 25 hours. This is 100 degrees for heating, 19 minutes. This is 120 degree percent and 15 minutes. So it is highest temperature increases. The heating is times is sorted. It's sorted. And the street strength, it is clearly changes. This is after different and the 100 degrees for different times. These two pictures. So this is the rheology properties of the cycles deformations experiments. So it is cycling deformations. We can see the dynamic strength, the empty cycle test. It is shows the suckling properties. Suckling properties, and the stain, it is persistent the 100 to 500%. The strength covered is fixed at the 100% stains after different wetting times. So this is schematic elastomers of lubrication of the WP is a set composition conductors. The fabrication process of the hearables conductor composition conductors. Setting dispersions contains a little amount of the emulsions was sprayed on the first layer. So it states this is emulsions. Acetylene break. Acetylene break dispersion in emulsions, and onto the coating the first conductive to form the conductive layers, and to the emulsions with the nanoparticles in the emulsions, the traps castings. The operating when the solvents when to the UV light, it is exposure for certain times and release less. The acid conductivity layer is forms. This forms, it is have the heatable polymers, and to photograph this composition conductivities. So this conductivity of the WPU's composition conductors. This is originals. This is the cut to cut off. This is held to few minutes. This is healing the 1 hours. 1 hours at the 100 degrees centigrade. And this is recycling behaviors is good. Down the three pictures, it is before cutting conductivities. It is the conductivity, the light, it is on, and to part, a light is up. It's done. When we are healing to after and light relight on of the light. So it's good the healing ability and with a good conductivities. So we have the prepare the visible fraction sensors associated PU is assessed. This is fabrication fraction sensors for human motions detections. Those it is a finger. It is finger. My uh, sensor flex attached a finger. Finger. It is a bank. A bank 0 to 90 degree. So we can conduct the human motions directions. This is the human signals with banking. It is good sensitive. So this is part one. It is conclusion. Part one conclusion. The double network science principle for synthesis environment friendly the chemicals using curing waterborne polyurethanes. And WPUs contains the loosely cross-linking networks obtained curing of the double bonds, and the physical cross-linking networks was produced by the UPA units in the polymeric networks. The urethane polymers possess the high stress and good resilience with factors self-healing performance. A conductor possesses both excellent inherent and unique mechanical behaviors. For the poor of the concept experiment suggestions, the composition conductor can be employed to flexible sensors of human skins by the successful detector by signal of the finger and the outer bandage. So this is part one. Next is the contents two. Self-healing the silicone elastomer. This paper, it is just published on the Chemical Engineering Journals, 2020. So this is, we have the prepared photo-curable silicone materials, and to the self-healable UV curing the silicone materials, and we have used the UV curing technology and the silicone materials aggregate to this have many advantages: a simple reaction conditions, structure controllables, and rapid curing rate, and energy conservation and environmental protections. So it is a shortcoming. Traditional silicone material have the many shortcomings. The opacity and pure mechanism properties and small cure rates and comfort. So we can UV curing kinetics to the silicones. We have to prepare the self materials have the many advantages such as the long-term usages, reliabilities, durability, cost reductions, and to prepare hearable materials generally have the two methods, the intrinsic and the extrinsic. We have used the intrinsic. So we have traditional silicones. It is no parents and no resistance policies. We have developed the overcome. We have the prepares the overcome wearing 3-dimensional printings of the silicone elastomer have not yet abilities. So We can research in vinyl terminase and polysiloxanes, PDMS, polysiloxane PDMS, and have the photothermal direct curings and mechanism properties, good mechanism properties, physical properties, dynamic reversibilities, soften heating abilities, reprocessing abilities, transparent, hydrolysis-resistant, and applies in the 3D printings. And two, we have used the vinyl ending groups and to the polysilicones, and the slow modified the silicones of the PDMSH, and the carboxyl modified the silicones, and amino modified silicones of else plus the photoinitiator. So we can compress the conformation of the curing the systems to prepare the softened curable silicone materials. We have also studied the UV curing kinetics and using many techniques to own the characteristics such as the FTIR, DSC, NMRs, XRD, etc. This is the schematic illustration of the photothermal Darwin curing the cross-linking networks, the silicon elastomer. Elastomer, this is the false material, the precursor. This is three medical silicons. This is double bonds and groups, and to the conforms the branching structures, the prepolymers, and we use the TPOL as the photoinitiator. When the UV exposure close linkage, it is opening, and using your carboxyls and no cells to the combination and to close linking. Well, have the small heat curing and silicon, and to the and to forms the two hydrogen bondings. So it is finished the small Darwin curing and close linking networks of the silicon elastomer. This is the small Darwin curing mechanism properties. This is the in situ knowledge test. This is the retimes FTR. Retimes FTR just means the studies to the UV curing kinetics. We should catch the double bonds of the conversion. It has increased up the 90%. Only 20 seconds. 20 seconds. So it is very fast. One is the UV light. UV light, it is 30 seconds. So it is duration, it is opened. Duration, it is opened, and the G, it is increased sharply. Okay. This is FTIR spectrals and the a special absorbs peak and many of the peaks changes with the UV curing. This is XRD degraded grams. This is a stress to dense cubes. So it is so that we have the persistent 2000 200, 250 and 50 to 300, 300% the breaking loss, So this is the wired temperature FTIR spectroscope, and we have the use the 120 degrees centigrade, and from the 30 degrees centigrade increased to 120 degrees, the a special peaks the septon. It is rich septums. When the temperature it is decreased from the 100 degrees 20 degrees centigrade to the 30 degrees centigrade, the peak chapter it is back to this. It is clear. So it is dynamic reversible photo small crosslinking the silicone's elastomer. This is storage modulus. This is that when the highest temperatures, the modulus it is decreased. But with we can to the silicon crosslinking samples, so it is persistence the storage modulus. It is certain values. It is persistent. Certain values. This is dynamics reversible photo small crosslinking silicon elastomer. Elastomer, it is novelty stress relaxation curves. A is a different temperature. B is a different ion bonds at the 60 degrees centigrade. As figure C, it is a similar feature of the relaxation times. Time relaxation time with the temperature according to the Arrhenius equations. dA stress relaxation activities energies EA of the sample with various ion bonds. So it is the rules, the good rules, and we have the proposed way of studies. The Herein abilities. So it is cross-linking to the cross-linking and cut it to pounds and to Herein together, recut together. This is photographs. Repeat macros repairs of the small TENIL samples. So we can see the patch and the requires the good together. So it is repeated the heat and persistent the good stress and mechanical properties. So which is the next next the paragraphs show the have the good elastomer. This is huge 100 degree for the 20 hours. Here to 20 hours. So it's the processing. We have the a silicone elastomer and the switch the small particles, the small particle powders, and we have used the small and compressing the press, the press, the plating, and to prepare the samples and to dimension cut off, and uh, again sample self-curing together. So which this is this message, it is used the reprocessing of the ability for the silicon elastomer. This is the transparent of the hydrolysis-resistant. We have the changes. We have the good transparencies from the 19% to 95%. So we different the samples slightly decreased but a little. So the have the good appearances. This is sampling of my university, Guangdong University of Technologies, the samples, as persistent the good mechanical properties. This is storage modulus. It is the changes with different temperature or the different samples. So we can use this silicon elastomers, use the 3D printing based on the SLA. This is the deformation of the structures. So it is printing this moon star, and we can to cut 2 pounds and Herein to Herein and recombination together. This is GDUT. Is the melted stars have the good health ability, have the good mechanical properties, and the self-healing abilities. It is up to the 95% for the mechanical properties. So it is conclusions. The self-healing, the recycling, the silicon elastomer realized by use small coatings. And the second is a self-healing and recycling additives derives from the reversible ionic crosslinking. And the silicon elastomer was transparent and the hydrolysis-resistant, and the silicon elastomer would be 3D printed and to the self-healings of the softened device. So this is references. This is recent. My teams published the papers. It is the progress in polymer science and the progress organic coatings and Journal of the Material Chemical Part C and the Chemical Engineering Journals and the ATR polymerase silica and cover paper. So, acknowledgement. This is my postgraduate. This is Dr. Yang Yan. This Dr. Liu Zhu. This is Dr. Zhou Junyi. This is Associate Professor Xiang Hongping. It is my post-PhD. This work has been finished by the PhD students and teachers in my groups. I thanks all of their contributions. So this is celebration of the my Teachers' Days in Guangzhou, 280 in China. This is look my teams, my students. It is lovely lectures.